Hi class. Let's assume that data are cleaned and prepared for analysis. Now we are ready to check the quality of survey items. For survey questions that produce quantitative data, a rough way to conduct item analysis is to check the discriminative power. I have an example data set opened in Spss. This is the variable view of the data set. In the data view, go to Analyze, Descriptive Statistics, and Frequencies. Here, let's just select a few items that have Likert scale responses. Go to Statistics. In this pop-up window, find percentile values at the upper left corner and ask for 33 percentile, add it to the list, and 66 percentile and add it too. It doesn't hurt to also include minimum and maximum values. Click Continue and OK. Now we're looking at the output window. The information allows you to compare the responses of the top 1/3 and the bottom 1/3 of individual items to examine the item's ability to discriminate. You can see that 3 out of the 6 items have the value 2 at the 33 percentile, and 3 items have the value 4 at the 66 percentile. But for question 1, both 33 and 66 percentiles have a value of 4, and for questions 3, both 33 and 66 percentiles have a value of 2. This indicates that the 2 items have very little power to differentiate respondents. In other words, if the responses that separate the bottom 1/3 and the top 1/3 are the same, the item appears to have very low discriminative power and it needs to be revised or removed. In SPSS, you can get Cronbach's alpha to measure reliability. In this data set, I have a battery of 7 questions that measures informal social integration. Come to the data view of the file, start from Analyze, then go down to the place called Scale, and there is an item called Reliability Analysis. Click on it. From this list of variables on the left, I'm going to identify the 7 questions that are in this battery and bring them to the upper right panel called Items. The first question I have for this subscale is question 4, but it's a negatively worded question, and I have reverse coded it into Q4R. Then I have Q5, Q6, Q7, Q9, Q16, and finally, Q8 is another negatively worded question that I have already reverse coded. So I'm going to include Q8R instead of Q8. The default setting will produce the Cronbach's alpha value, but I recommend that you click the Statistics button and require the correlations as well. Let's continue. Now we're ready to click OK. In the output window, a table has the Cronbach's alpha for the items that measure the informal social integration. The reliability is 0.862, which is pretty good. The same procedure needs to be repeated for every subscale that measures unit-dimensional constructs. What would happen if you forgot to reverse code variables that were negatively worded? Still use the above example of informal social integration, but this time I get the reliability using the original Q4 and Q8 instead. This can be easily demonstrated using syntax. After I paste the syntax, I'm going to change Q4R and Q8R, the two reverse coded items, back to the original variables Q4 and Q8. Highlight this section of syntax, click Run, and you can see that the Cronbach's alpha value is reduced substantially to 0.538. When the reliability is low for group items that you believe measures the same construct, remember to first check their bivariate correlations. Based on this correlation table, it's clear that Q4 and Q8 are problematic because both of them have negative correlations with other items in this subscale. From the previous run, we already knew that reverse coding will fix the problem. What if the Cronbach's alpha is still lower than expected after negative items have been reverse coded? In the dataset, another subscale of financial pressure has a battery of 4 questions. Q37R, Q38, Q39, and Q40. Let's pretend for some reason I believe that Q1, my academic program, is of good quality, and Q18, I find every day enjoyable at my university, should be included as part of the battery measuring financial pressure. If I run reliability check for the 6 items, the Cronbach's alpha value is 0.608. Remember that we first need to check the bivariate correlations. It's apparent that both Q1 and Q18 have consistently low correlations with other items in this subscale. I'm going to use syntax again to do several things. First, let's remove Q1 and get the reliability. The Cronbach's alpha value is approximately 0.67. Now let's remove Q18 and get the reliability. The Cronbach's alpha value is approximately 0.66. Both are better, but not enough. How about we have both Q1 and Q18 removed from the battery of questions and check the reliability one more time. This battery of 4 questions now have a Cronbach's alpha value of 0.773, which is pretty good. This example shows us that the statistical evidence suggests that Q1 and Q18 are not measuring the same construct and should be removed from the subscale measuring financial pressure.